As you can see, INP is now part of the overall Sentry performance score. We can also focus solely on the INP component of this score and see how we can improve our application responsiveness with it. Clicking on that component, we can monitor INP performance over time. There's also a list of pages within your app ordered by the highest opportunity, which measures how much the INP of that specific page contributes to the overall INP score. For this example, we're going to look at our Discover homepage, where users can query their Sentry events using a range of custom filters. We can see that the INP opportunity score for this page is quite high, which means there's a lot we can improve here. Clicking on the link takes us to the page overview with a list of samples, each representing a single user's experience of Discover. On this page, we can see there's a range of interaction response times. Let's look at an example of a slow interaction by opening a replay. As you'll see, when the user clicks a button on the page, it takes up to 3 seconds for the modal to load, which is why our INP is so low for the user's experience of our Discover homepage. Now that we know the issue, or the what, we can actually go back to the Web Vitals workflow to determine the root cause, or the why, using profiles associated with each sample. Each profile collected in production from the user's browser can actually show us how long JavaScript code took to run at a function level. By identifying slow functions, we can find code paths that impact INP. The timeline at the top represents spans, the various operations that can take place when loading or interacting with a page, including resource loads, API requests, and user interactions. For our example, we can see a UI interaction click span with a duration of 3 seconds, equivalent to the user clicking on the button we saw earlier in the replay. Looking below the span, we can see the call stacks for code executed during the span. Specifically, there is an on-click frame that calls compute modal placement. We can see that getBoundingClientRec gets called many times sequentially within this function, which is why the user's interaction is taking so long to process. We can probably fix this by optimizing compute modal placement to not call getBoundingClientRect so frequently. Alternatively, we can update our code to yield the main thread between each call so we don't block rendering or other interactions from occurring. Now that we know the root cause, hovering over compute modal placement shows us which line and file the code is called from, so we know where to apply our fix.